Hello everyone, this week's topic is emotion and how we communicate our emotions. I think this topic will interest you a lot because as counselors we are always working with the emotion part. When I especially ask reflection papers for my students to write in my classes, I always ask them about the reflection of their feelings, because feelings, emotions are at the core of any counseling intervention. Hence, this is an important and to me it's an enjoyable topic actually. Let's firstly define what emotion is. Actually, it refers to positive or negative reactions to particular situations. And there is nothing as a neutral emotion. With a reaction to anything coming to you from outer world, you have a specific emotion. For example, if you are treated unfairly, then this will make you angry. Or if you see someone suffer, then you will most probably feel sad. And if you are close to someone whom you love, this will make you happy. So we don't have any neutral emotion. And emotions consist of patterns of physiological changes and accompanying behaviors. And when we are considering emotional responses, it will be okay to say that there are three types of components actually: behavioral, autonomic, and hormonal, and we will go through them now. Firstly, as you see, the behavioral component refers to muscular movements, like, for example, if a dog is defending its territory against an intruder, first threatens the intruder by adopting an aggressive posture, growling, and showing its teeth. If the intruder doesn't leave, the defender runs toward the intruder and attacks. Okay? Here, for defending the territory, the dog displays lots of behavioral components of emotion, such as posture, growling, showing its teeth, and the basic emotion behind those movements, those muscular movements, is aggression. Okay? And also we have some autonomic responses actually. They facilitate the behaviors and provide quick mobilization of energy for movement. For example, the activity of the sympathetic branch of the autonomic nervous system increases. You already know about sympathetic nervous system, right? And there was also a parasympathetic system. Here, what is activated is the sympathetic one, and parasympathetic branch decreases. As a consequence, the dog's heart rate increases, and there will be observed some changes in the size of blood vessels, which shunt the circulation of blood away from the digestive organs throughout the muscles in order to defend the territory. Okay? And these are the autonomic responses. And we also have hormonal responses here, as you see. Hormonal responses. They reinforce the autonomic responses. The hormones secreted by the adrenal medulla are epinephrine and norepinephrine. You already know about these. And they further increase the blood flow to the muscles and cause nutrients stored in the muscles to be converted into glucose. And totally, as you see, behaviors, hormones, and nervous system acts together in order to trigger the emotion behind. So they work together at its most. And now we will briefly mention especially the negative emotions. Since most of research on the physiology of emotions has been confined to fear and anger, and which are associated with situations in which we must defend ourselves or our loved ones. For example, if I ask you to explain fear and anger and their association with defending someone or ourselves with the approach of natural selection, how would you describe it? Or survival of the fittest approach. Okay, think about evolution and how we survive, and try to make some linkage between the existence of fear and anger with the ability to survive in life. Maybe here you would need to take into consideration the role of sympathetic nervous system as well. Okay, fear. And as we see, the emotional responses involve behavioral, autonomic, and hormonal components. And we see that the integration of these components of fear appears to be controlled by the amygdala. If you want to watch a detailed video on how amygdala proceeds, you can get to this YouTube link, okay? Okay, for fear, for the emotion of fear, let's go with the research which were done with humans. We humans acquire conditioned emotional responses. For example, suppose that you are helping a friend prepare a meal. You pick up an electrical mixer to mix some batter for a cake. Before you can turn the mixer on, the device makes a noise and then gives you a painful electrical shock. And your first response would be a defensive reflex. You would let go of the mixer, right? Which would end the shock as a result. And this response is specific. It is aimed at terminating the painful stimulus. In addition, the painful stimulus would elicit non-specific responses controlled by your autonomic nervous system. Your eyes would dilate, your heart rate and blood pressure would increase, you would breathe faster, and so on. And the painful stimulus would also trigger the secretion of some stress-related hormones. Suppose that a while later you visit your friend again and once more you agree to make a cake. Your friend tells you that the electrical mixer is perfectly safe, it's been fixed. Just seeing the mixer and thinking of holding it again makes you a little nervous, but you accept your friend's assurance and pick it up. Just then it makes some sputtering noise that it did when it shocked you. What would your response be? Almost certainly you would drop the mixer again, although you didn't get that shock at that point. And your pupils would dilate, your heart rate and blood pressure would increase, and your endocrine glands would secrete some stress-related hormones. In other words, the sputtering sound would trigger a conditioned emotional response. You will see this conditioning situation in psychology of learning class, but maybe you already know from Pavlov's dog classical conditioning approach. Actually, this is taking its basis from that classical conditioning approach. If you associate something with something that hurts you, for example, in this case there is a pre-experience about the electric mixer, and then the next time you have associated getting electrical shock with the sputtering noise of the electric mixer. Okay, so although it didn't give you some shock, the noise made you afraid of the situation. Okay, so this is conditioned emotional response. Most human fears are probably acquired socially, not through first-hand experience with painful stimuli. For example, a child doesn't have to be attacked by a dog to develop a fear of dogs. He or she can develop this fear by watching another person being attacked or by seeing another person display signs of fear when encountering a dog. So this is learned socially. And also, you can acquire a conditioned fear response through instruction. For example, suppose that someone is told that if a warning light in a control panel goes on, he or she should leave the room immediately because the light is connected to a sensor that detects toxic fumes. If the light does go on, the person will leave the room and is also likely to experience a fear response while doing so. So someone instructed me about doing something when something happens, so I formed that fear by the instruction I have held. Now, what about your fears? Consider your fears. How many of them and which of them you acquired socially, either by maybe seeing your parents, your partners, or watching other people, or by instruction. I wonder them a lot. Okay, if we are done by fear, just let me just do brief summary. The important thing you need to know is that fear appears to be and its associated components are controlled by amygdala. Research done with humans indicate that most of the emotions are acquired throughout conditioned situations, and also we should know that fear is learned socially and by instruction. Okay, there are 3 ways according to the research the fear is acquired. And now let's go with anger. Almost all of the species of animals engage in aggressive behaviors, which involve threatening gestures or actual attack directed toward another animal. Aggressive behaviors are species-typical, that is, the patterns of movements, for example, posturing, biting, striking, hissing, are organized by neural circuits whose development is largely programmed by an animal's genes. Okay? And many aggressive behaviors are related to reproduction. Okay, remember my previous question about natural selection and survival of the fittest? Maybe you can utilize it here. For example, aggressive behaviors that gain access to mates defend territory needed to attract or to provide a site for building a nest, or defend offspring against intruders, can all be regarded as reproductive behaviors. Okay, and other aggressive behaviors are related to self-defense, such as that of an animal threatened by a predator or an intruder of the same species. And when we examine the research with humans, we see that actually human violence and aggression are serious social problems. And I think what will mostly interest you is this part. You should know that the frequency of bullying and cyberbullying and vandalism is increasing at schools, which should be examined and actually which is researched a lot in the last decade, let's say. Okay, these are all research done with how the anger in humans is expressed out. When you bully someone or cyberbully or do something vandalist, actually this is a reflection of how weak you are. But you are not able to face with the reality of your weakness. So since you are not able to face it, you try to reflect it out in the form of bullying or vandalism in order to make other people think that you are strong. Or maybe you are trying to make yourself believe that you are strong, but actually you are not. So as counselors, this is an important point that you are gonna work with at especially school settings. Okay? And let's go through the factors affecting aggression. Actually, there are some other role of heredity in factors affecting aggression. Early experiences can certainly foster the development of aggressive behavior, but studies have shown that heredity plays a significant role. For example, in a study with a group of same-sex twins at the ages of 7 and 9 years old, they found a higher correlation between monozygotic twins than dizygotic twins on measures of antisocial behaviors and unemotional behaviors, which indicates a genetic component in the development of these traits, and no evidence was found that a shared environment played a role. To go on with the factors affecting aggression, actually we can refer to the role of serotonin. Okay, several studies have found that serotonergic neurons play an inhibitory role in human aggression. For example, a depressed rate of serotonin release are associated with aggression and other forms of antisocial behavior, including assault, murder, and child beating. And now we will continue with the communication of emotions. Here, the important thing is that in the communication of emotion, facial expression of those emotions are important. There is this neural basis of the communication of emotion in the form of recognition and expression. Okay, first let's go with the facial expression of emotion as innate responses. Here, you know Charles Darwin. He has suggested that emotional expressions are innate. They are unlearned responses consisting of a complex set of movements, principally of the facial muscles. If I'm smiling, see, I'm smiling. What is happening is that my mouth is being opened, also my pupils, okay? I'm smiling. And the research has found that in spite of little social interaction in some of the tribes, they were displaying the same ways of facial expression of emotions. Hence, Charles Darwin defended the idea that the facial expression of emotions are unlearned. Thus, a person's sneer and the wolf's snarl are biologically determined response patterns, both controlled by innate brain mechanisms, just as coughing and sneezing are. And some of these movements resemble the behaviors themselves and may have evolved from them. Okay. And this is the logical argument behind the innate nature of emotional expressions. Okay, and let's go with the neural basis of communication of emotions. This is recognition. Under the recognition part, we will examine the laterality of emotional recognition and role of the amygdala. Firstly, effective communication is a two-way process, and that is the ability to display one's emotional state by changes in expression is useful only if other people are able to recognize them. Okay, I'm doing this, but nobody recognizes that I'm happy. Okay? So, they found that the scientists found that happy situations, for example, experiencing a beautiful day, produced only small signs of happiness when the people were alone. However, when the people were interacting socially with others, please see that laughing triggers laughing, and here is a video for you how it is triggered. When we recognize other people's feelings by means of vision and audition, seeing their facial expressions and hearing their tone of voice and choice of words, many studies have found that the right hemisphere plays a more important role than the left hemisphere in comprehension of emotions. In one research condition, the subjects listened to the meaning of the words and said whether they described a situation in which someone would be happy, sad, angry, or neutral. In another condition, they judged the state from the tone of the voice. The investigators found that comprehension of emotion from word meaning increased the activity of the prefrontal cortex bilaterally. For example, try to guess. What is my emotion here? Oh, you only hear me. Come on, and just please sit down. How do I feel here? Or, come on, just sit here, please. Okay, are you able to guess how I'm feeling under these two situations? Okay, so here this refers to how we recognize the emotions of other people. And let's continue with the role of amygdala. Actually, amygdala plays a special role in emotional responses. It plays a role in emotional recognition as well. Functional imaging studies have found large increases in the activity of the amygdala when people view photographs of faces expressing fear, but only small increases when they look at photographs of happy faces. So we had mentioned while we were talking about fear, about the role of amygdala. Actually, amygdala has a big responsibility in the trigger of the emotion of fear. Okay. And lastly, we will talk about the neural basis of the communication of emotions, which is expression. Facial expressions of emotion are automatic, and it's not easy to produce a realistic facial expression of emotion when we don't really feel that way. For example, I have a facial expression, which is this. And my friend, one of my closest friends, notices that this is not the real happy face of Burcu, but this is the face of Burcu stating that, okay, oh my god, okay. But if you look at my gesture, this is smiling, indicating that I'm happy, but it's not real. So, the research, especially Ekman and Davidson, have confirmed an early observation by a 19th century neurologist, Benjamin Duchenne, that genuinely happy smiles, as opposed to false smiles or social smiles people make when they greet someone else, involve contraction of a muscle near the eyes the lateral part of the orbicularis oculi, now sometimes to referred as Duchenne's muscle. Okay, so according to Duchenne, if you are faking a spatial emotion, it will be obvious with that so-called Duchenne's muscle. Okay, and here in the YouTube link you can see how Duchenne has regulated his experiment. Okay, today we talked about the nature of emotion and how it is communicated and how it is recognized and expressed, and how it's actually a two-way process. If you have any questions, you can ask. As you see, there is no mandatory question you need to answer for this week's class, but if you have any comments, if you have anything that you didn't understand, please write below the video so I will answer it. Take care. Bye bye.